I highlighted problems in green today. You should see that the title says 4-8 Part 2 Homework 2020. The problems in green are the problems that I could potentially be grading. You don't have to do the other problems. It's always encouraged for you to do whatever it is, you need to do your extra practice. When I was grading this morning, I did notice some students have learned how to do some of these, either A, through Photomath, or B, through some type of online calculator or something, and you are only writing the final answers and not showing your work. You will never receive full credit on that. If you need further details, please refer to the syllabus that I presented at the beginning of the year. You got to know how to do something unless I say otherwise. Okay, so let's just do a couple of spot checks. So I have 3 kids in class. We'll have one of them pick any problem they want, and we'll work through that problem together. And if you're lucky enough that they pick a problem that's graded, that's awesome. And if you aren't, then that's unfortunate. I'm also going to ask the kids at home to share their screen. So that will give us at least a total of 5 problems being done. If you didn't do your notes, obviously those need to be done. If you are not passing this class, that'll be the first thing I ask you to pull up and show me are your notes and that you are watching the Zoom meetings. All right. All right, my student selected to do number 1. So I am going to ask her to screen share. Wonderful. All right. So I'm going to guess that you already have that little thing pulled up. Do you already have your little perfect square sheet on there? Good. Show them how to do it, because when I grade your homework, it's always on there, so I always know that you kind of know what steps to take. So it's great. Good. So she's going to look and see if there's a square root of 49. Yes, there is. What is the square root of 49? So it's a perfect 7, and the negative becomes an I. That is correct. Good. So the negative comes out, becomes an I. She has nothing left over. There is no need to show work because that was a perfect square. If it was not a perfect square, she would have to show work. Buddy? I have another student who would like to walk through number 40. So everybody go ahead and zoom to number 40. Okay, so the first thing we need to make sure is that it's set equal to 0. Is it set equal to 0? Yes, it is. So now we're going to do, the direction said solve, so we may as well just go straight to the what? What's that formula? Quadratic formula. Good. Opposite b, plus or minus square root b squared minus 4ac all over 2a. Do me a favor, extend your fraction bar to be under your 3 as well. Thanks. All right, then he's going to drop down 3 plus and minus square root. He's going to type that in his calculator. Good. Excellent job. Thank you for showing everyone. That's perfect. Watch exactly what he's typing. I want you to type it exactly as he is. Don't be a mooch. Everybody make sure you're typing in your calculator the exact same way he is. He's doing a fantastic job. Very good. What did you get there? Negative 31? Negative 31. All right, throw that in your, that's good. All over 2 times 2, which is good. Now, I need to ask him to bring down what? What do we bring down? Let's start with the easy part. On the outside, we bring down the first thing that you wrote before. So the 3, yeah. So 3 plus or minus. Now for the hard part. Actually, let's put all over 4 because that's not changing. Okay, now let's talk about this difficult part. Is 31 a perfect square? Is there anything that goes into 31 that is a perfect square? No. Can you bring an I out? Yes. Why can you bring an I out? because it's negative inside. Very good. So bring your eye out. Miss Miles will say, take your eyes out, but don't go blind. Draw a square root. And you indicated nothing goes into 31. So that is the ugly answer. Let's see if anybody can answer this. Does this cross through the x-axis? Since he got an imaginary answer, does it cross through the x-axis? Yes or no? If you get an imaginary answer, does it cross through the x-axis? The answer is no, it does not. All right. Everybody scroll to number 7. I have another student who's going to solve number 7 for us. And you can screen share right over top of, good, just hit the green, you know, yeah, you got the steps. Screen, start broadcast. It's going to ask you if you just want to share over top of that, and it should just let you. Yeah, good. All right, number 7. Let's zoom into that one. Let me see what's going on. Now, what I'm noticing about this problem is that the real portion of it is missing. The imaginary part of it is good. So go to number, go scroll up. Yeah, I know I had one on here for you just like it. That is fantastic. Wonderful. If you guys are wondering what a good set of notes should look like, it should look like this. That's good. Zoom it down. Pull your, yeah, go to part B there. Not that one. Go to part B. Notice how this one lines up exactly with number 7. So there was no real part. The real part was 0. So you went over 0 and up 6 in your notes. So since there is, can you write on this problem, would you write 0 minus 3i so people understand what I mean by the real part being 0? Okay. So since the real part is 0, you go over 0, and then on your imaginary axis, you go down 3. So where would the point be? That is correct. That's it. That's all there is for the plot. Now, the absolute value of it is a different story. Follow what you did in your absolute value part there. So on your notes, you did the absolute value of, do you know how you got those numbers? Yeah. So you had to do the square root. You had to square your 6 on your notes. So on this one, I need you to square your 3. What's 3 squared? Yep, plus what's 0 squared? Yeah. So you end up getting the square root of. Does that reduce? Done. Good. That goes in that's your absolute value. I don't know if you want to like draw a line to it or not, but that answers the absolute value part. Good job. Okay, I'm going to pause my recording and I'm going to grab somebody online. All right, we are going to go over number 2 now. So I will ask my student, is there a square root of 144?
Yeah.
Yes, what is it?
12.
That is correct. So write a 12 there. And since there's a negative inside, what does the negative become when you pull it out?
An I.
Yep. And that is the end of that problem because there's nothing left over. Very good. All right, my next student says they are willing to solve number 8. So let's take a look at what she does. Looks like she went over 6 and down 4. Now, that particular line is not needed, okay? The dot, just the point itself is the plot. The line is how far away it is from 0, which is what the absolute value tells us. So how do we do the absolute value of this thing? It's not like you would normally think. It's not just like 6 plus 4. It's weird. So you square the 6. Put a little squared behind both of those for me. Good. So that's going to be the square root of plus. Good. Go ahead and put a square root on those. And then add them up. Hold on one sec. Put a square root around that because you're not quite done. You have to put a square root around them. I don't know if you remember from geometry or not, but we're essentially doing the distance formula. The absolute value of an imaginary line tells you how far away it is from 0. So by applying the distance formula, it's almost like a right triangle. You're really doing a squared plus b squared. of a right triangle and taking the square root. You're telling it's the dot that she plotted, you're saying how far away it is from 0. So you did a good job, but do you know why, if I were grading this particular problem, I would have to take a point off? Probably a half a point off if you showed as much work as you did. But do you know why? Does anybody know why I would have to take a half point off her answer? You did not forget an I. Nope, because the absolute value is always positive. So we won't have a square root of a negative there. Nope, not gonna equal 0. You didn't check to see what went into 52. So you remember that little list you have at the top of your paper? What number on her list goes, or on everyone's list, what number goes into 52? Does anybody know? 4. 4 times what? Good. So go ahead and erase your box and write 4 times 13. Yeah, put a square root around that. There you go. And then the square root of 4. Nope. What is the square root of 4? 2. And then the square root of 13 goes behind that. Good. That's your answer. See the difference? Yeah. So the square root of 9 is just 3 with no leftovers. 9 is a perfect square. That's an excellent question. Yes. So in the problem my other student did, the square root of 9 was perfect. This one was not perfect, so she had to go to her list. All right. I will go ahead and screen share. I will solve one for everybody, and then I will end the recording to make sure we have some accountability for the people who are watching the recorded Zoom, and that they're not just copying all our answers. We have not done a factoring problem, so let's go ahead and factor number 37. Okay, so if everyone wants to scroll number 37, I will happily factor number 37. And again, I have beside me which ones I grade. I'm not even looking at it. I just randomly picked a problem. I may or may not grade number 37. Okay. What is the GCF in number 37? There is. It's a really obnoxious one that nobody usually sees. It is a -1. We never want that first term to be negative, so we have to pull out a -1. Now, I pull out a -1. What is that going to make this statement up here? If you pull a -1 out of each of those, what does the first term become? Yep. What about the second term? Good. Plus or minus? Yep. So now you have to be able to get yourself to where you can see this is the sum of perfect squares. This is the sum of perfect squares. Now, if it was the difference of perfect squares, it wouldn't be imaginary. But because it is the sum of perfect squares, we are going to have imaginaries. So you bring down your -1, you write your factoring parentheses, and you take the square roots. What is the square root of 4x squared? What is the square root of 4x squared? Good. That goes there and there. What is the square root of 49? Good. One's a plus, one's a minus. And because it's the sum of perfect squares, we need an I and an I. Otherwise, we would have the difference of perfect squares without the I's. That is correct. Yep. Yep. And all of these will behave that way. The only other one that has GCF is number 34. So take out a 5 before you do your square rooting. All right. I will do you guys want 38? That's the answer. That's the fact. Yeah, it says to factor it. So yeah, that's the answer. That's the factored form of it. There's no solving. Okay. I would not mind doing another solving problem for you. I had one of my students did number, I think you did 40, didn't you? Does somebody want to do another one? Does somebody want to do another one? Grace. Oh, I just said her name. So at number 6, she did a fantastic job taking out her I because it was negative. Now she's trying to figure out what goes into 48 on her list, and she found 16 times 3. So the square root of 16 is 4i square roots of 3. Good. Okay, we're going to look at number 25 together. 25 is kind of unique because it's not like you're going to multiply the 2 parentheses together because it's separated by a subtraction sign. So in the first parenthesis, you're going to distribute a what? Just like that. That's it. So go ahead and do that part first. So 2 times 3 is, and 2, yep, that looks really good. Okay, now in the second parenthesis, yeah, just like that. So what is a negative I times a negative 4? Excellent. And what's a negative I? Yeah. Come on. Yes, excellent job. Now I want you to circle, wait. Everybody from Friday, what is I squared? I squared is a negative 1. So wait. What you're doing is good. You circled those, put those together. What's negative 14 plus 4i? Negative 14i plus 4i. That's good. Now, on the next step, we just said I squared is a negative 1. So what is that going to change your minus 5i squared to? Anybody? A plus 5. I squared is negative 1. Therefore, it changes the sign. I'm going to say that again. Let that sink in. I squared is a negative 1. Therefore, it changes the sign. And then it goes away. All right, so we have 6 plus 5 now that we can put together. And now you're all done. Good job. So we have a request to look at number 20. Would you mind pulling up your notes side by side here? Yeah, you got it. Good job. Those ones aren't it. Zoom in. Go up for me. Yeah, let's go back to your homework. I think we might have had these on the last. Yeah, I think we had these on the last side of notes. All right. So you see the square root of negative 16? We had to fix that first. So we're going to rewrite our problem. So draw parentheses. So it's a minus. Do 6 minus. Yes, 4. Not just 4. The square root of negative 16 isn't 4. The square root of 16 is 4. What's the square root of negative 16? Nope. I. The negative comes out, becomes an I. Close your parenthesis. Plus, draw your parenthesis. Negative 4. Plus, bring down your plus sign. Okay. Good. The square root of 25 is 5, but because it's a negative 25, she had to bring down an I. Okay, now you see the sign between those? Are we going to like do 6 times negative 4, 6 times 5i, negative 4 times? Are we going to do all that? You're just going to combine like terms, circle your plus sign. Because there's a plus sign in the middle, you just combine your like terms. So she has 6 minus 4, which makes, or 6 plus negative 4, however you see that, 2. And then negative 4i plus 5i. That's it. Very good. I think we've done one of each type of problem now. So unless I have any volunteers to do one more on the bottom portion of today's homework, I'm going to stop the recording because we have done more than enough. Does anybody want to volunteer for one of the ones on the bottom of the paper? You can say no. That's perfectly fine. We've already done one. Okay. The bottom 6 problems, you do the quadratic formula. Each time you'll be taking an I out. Otherwise, it's the exact same as the quadratic formula from chapter 4, section 7. I'm going to stop the recording. If you have any more questions, there is a problem in your notes that matches identical to each problem in the homework. Please come to the live Zoom meetings when possible.